So, okay, so from here, okay, so from here we have already canceled this one. So what remains is just we'll group this one. You have dx, right? We have dx and dx, you have dv and dv. So we have negative, negative x dx minus v squared x dx. And we have here, okay, we could already have this one, minus vx squared dv minus x squared dv equals 0. So we have here all negative. So actually, we could also multiply both sides so to positive, or we could transpose everything to the other side so it becomes positive, right? So we can have, so that everything is a positive one, we could multiply this one with a negative one, or we could just transpose everything to the other side. So this negative becomes positive, this becomes positive, this positive, and positive. So what remains in the other side is still 0. So you have x dx plus v squared x dx plus vx squared dv minus x squared dv equals 0. So grouping this one will give you, have dx, we have x, so we have common of x and dx, so therefore we have 1 plus v squared times x dx. So let's check. X dx times 1, that is x dx. X dx times v squared, that is v squared x dx. Plus, common here, that is x squared dv. Right? So you have v plus, or yeah, should be positive. This should be positive. So when you transpose or multiply, plus 1 times x squared dv equals 0. So now we try to check x squared dv times v. So v x squared dv. X squared dv times 1, that is x squared dv. So from here, so let's continue. Okay. So from here, so medyo taas-taas dyan yung solution, guys. Okay, medyo taas-taas na siyang solution. So, medyo taas-taas yung siyang solution. Okay, so we'll just continue on this side. Okay, we'll just continue on this side. So now, from there, we could now we could divide this one, okay, with x, right? We could divide this one with x. So we have x here and x here. So therefore, we could simplify this one. So therefore, that becomes 1 plus v squared. So divide x, so mawa na si x ani, divide x. So what remains is just dx plus v plus 1. So x squared divided by x, that is just x dv equals 0. So from here, we could now use variable separable. So variable separable. So from here, what we need to eliminate this one because we have dx. So we divide this one with 1 plus v squared. And this side, we have v, so we need to eliminate the x, so divide it by x also. So dividing this one, so will give you just dx. So v plus v squared divided by this one, you have cancel dx over x na lang mabilin. Plus, divide this one, the x will be cancelled. What remains is v plus 1 over 1 plus v squared dv equals 0. Now, because we cancel this, when we divide this one with this, so ma-retain ang mga v, ma-cancel ang x. So from here, we clearly look this given, then they are clearly separated. We can now do integration. So we can just integrate this one. We could integrate directly. This one, you have identity like this, or we could extract this one. So plus integral of v dv over 1 plus v squared plus, so in this case, v squared plus 1, parihara na sila because the sign is positive, so we could interchange that one. So we have integral of dv over 1 plus v squared equals 0. So again, this 2 is just equal to this because same denominator. So when you add v plus, we have 1 here, so that is b plus 1. So with this, we could now integrate. So we could integrate directly. So, but we need to recall some identities here. Okay, from this one, you have this. Okay, so in this case, so aning kisa, so in this case, nakay ang u ni mo ani is 1 plus b squared. Ang du ni mo ani is when you derive this one, or this one, you have 0, you have 2v dv. So therefore, your dv is just equal to du over 2v. But in this case, you cannot use that one because you don't have any variable in the numerator to cancel. So from here, you could use this identity, which is you get your u. So this is a trigonometric one. So your u is just your, or u squared is just your v squared. Your u obviously is equals to v. Your a, so this is u guys. Your a squared is just equal to 1. Your a is still equal to 1 because that is 1. So what you need to remember here is your this one. Okay, so that the identity number 19, so I've given this to you on the past topics. I've given this all identities. So identity number 19 states that the du over a squared plus u squared is just equal to 1 over a arctangent of u over a plus c. So therefore, okay, we could maybe we can just extend it here. Okay, we just extend it here. Okay, so from this one, guys, let me choose the color. So, am I still clear? Okay, let me put me here. Okay, now, so from here, let's just continue. So from here, when end up there, sorry, so we end up here. Okay, so from there, what we need to do is to remember that that is this one, that the integral of du, okay, du over u squared plus a squared, or a squared plus u squared, because that is positive sign, so you could interchange it, just equal to 1 over a arctangent u over a plus c. So just check it later on. So it is included in the concept notes. So from here, you just integrate dx over x plus, so substitute this one. So we have integral of v. What is our dv? That is du over 2v. We have du over 2v over u, right? So this one is our u, plus integral of where u is v, Okay, u is b. Therefore, when you derive your u, that is du, derive your v, that is dv. So therefore, your dv becomes du over 1 is your a squared, because your a squared is still 1, plus v squared is your u squared, equals 0. And we know the equivalent of this one. So therefore, we integrate dx over x, that is ln of x, plus, we could cancel this one. So we have 1/2. So what remains is, move that 1/2, du over u, so ln of u, plus, so we have 1 over a, which is 1, arctangent u, your u is equivalent to v, u over a, which is still 1, equals c. So integral of 0. So we have integral of 0. So c. So from here, we could just we can multiply it by 2, or we can just go directly like this: ln of x plus ln of u raised to the power of 1/2, right? Plus, that is 1, arctangent v equals c. And our u is ln of x plus ln of, what is our u here? That's 1 plus b squared. 1 plus b squared raised to the power of 1/2, plus arctangent of v equals c. Remember, since we use y is equals to vx, therefore your v is just equal to y over x. So try to substitute that one, sorry. So we have long solution, so please bear with it. So from here, just substitute that v. So this ln x plus ln of 1 plus v squared raised to the power of 1/2, plus arctangent of v is y over x equals c. So from there, we could combine what we could combine. So this one, so you have, that is positive, so you have ln of x times 1 plus v squared. Again, we have v squared here, b squared raised to the power of 1/2. So okay, so sige, we'll just wait, no, 1/2 plus arctangent of y over x c. So your v also, we need to change this one, that is ln of x times 1 plus v is, or v here as we know it, that is this one, which is y over x. So y over x squared, so you have y squared over x squared raised to the power of 1/2, plus arctangent y over x equals c. So after that, okay, what do we need to do? Okay, so just simplify this one. You have ln of x times, distribute this one, so 1 raised to the power of 1/2, you still have 1, plus y squared times 1/2, that is 2 over 2, so you have y over x squared raised to the power of 1/2, that is 2 over 2, so you have x, plus arctangent of y over x equals c. So from there, you can distribute it. You have ln of 1 times x, that is x, plus x times y over